Hey everyone, Dave here. Today I want to continue with our NEP-5 tutorial, and I want to get started implementing the optional methods in the NEP-5 standard. So there's 3 optional methods in here: allowance, transfer from, and approval, that either are not implemented at all or are all implemented together. So you can't just pick and choose. These are all related to each other, so they all have to be implemented here. These optional methods allow for basically third-party transfers so that we can authorize someone here, or approve them. We can approve someone, the 2 here, to transfer an amount on our behalf. And then we can query that with the allowance, and we can do the transfer from is to allow them to perform that transfer. So why would you want this? The main reasons would be to delegate some or all of your funds, because we can set the amount here with the amount that we can give to the I'm going to call them a trustee to deal with. So let's say we're going on vacation and we're not going to be around, our wallet or our funds for whatever reason. We can entrust someone to deal with our funds for that period of time. The other thing would be third-party systems, right? So these would be exchanges, wallets, applications that we want to authorize to take some of our tokens out of our account and move them here. Decentralized exchanges may be one of the big users of these kind of things, depending on how they're implemented. So I side on the mindset of the less code you have in your smart contract, the fewer chance for bugs and the fewer potential places for security holes. So I'll leave that up to you to do your research whether you want to implement these or not. I'm just going to go over how to implement them. So let's get started here. And to do that, I'm going to take these methods here. So let's just take the first one and we're going to paste that into our contract here. So let's just get this all wired up, which will take just a minute. And approve here. And I'm just going to copy this transfer line because a lot of these actually follow very closely. Oops. Copy, paste. And allowance, I should have done that as 1. So let's just break these out here. So I'm just going to change the order of these a little bit into the way that we're going to implement these. So the first function I want to do is the approve function, which is going to take the originator, the 2, and the amount. So that's an address, the 2, and an amount. So that matches exactly up with the existing signature we have here. The allowance just has 2 addresses, and this is used to query what allowances are set up. And then the last one is the transfer from. So this is how a third party is going to actually initiate this transfer. So they're going to have to pass themselves in, who the funds are going from the account, and then who those funds are going to. So we're actually going to need to expand this here to be 2. And if you're cringing about cases, I will fix that right now. Okay, and approve, return. Just going to dummy these in here to get rid of some squiggly marks here. And I'm just going to reformat that. Okay, there we go. So the first thing we're going to do is we're going to implement our approve function. Actually, I'm going to change that. I want to just have a little revisit of this naming because it drives me up the wall. So approve takes in an originator, so who is sending in the approval, and then who the approval is going to. So this to me is what I would call a trustee, the person we're entrusting with our funds here. So I want to rename this to be approver and trustee. Now allowance is used to query that information. So I'm going to do that. So you notice that this one here was before was from instead of originator, right? So I'm going to say the approver and then the trustee, and then transfer from here. This one here is going to be the approver, because that's the account we're taking the funds out of. The person who's calling this, though, is the trustee. Trustee. And then the to is whoever we want to send the funds to. That can be anyone outside of, or anyone at all. Right? So by using this naming, at least we can see where they tie between each method. The way that it is here on the NEP standard is, you know, in this case, it's a from and to, but is that dealing with who funds are going to? Who are these actors in the system? Transfer from has all these originator and then from and to. Well, originator to me is the funds, like the account that the funds are coming out of. But if you read the remarks here, you'll see that they clarify those. So by taking this, we've got a little bit more of a standard naming convention. So let's implement the approve. The first thing I want to make sure is that no one can approve funds on our behalf. So we'll do a witness check. Runtime notify approver failure. And then what we're going to need is we're going to store this information. So we need to put this in storage of the approval. And what a lot of people do is they concatenate the two keys together to make one big key. So let's do storage.currentContext, comma, this is the approver. Concat is an extension method we can actually use. It is supported by the Neon compiler, and it probably has an operation code to do this work. And then the parameter here is going to be the second, be the trustee. And as the value, we're going to store the amount. So we're going to put into here owner plus the non-owner, the two wallets that I'm using here. That's going to be our key that we're going to store. And if that is successful, we're going to return true here, which it should simply store it. And all allowance is going to do is it's going to retrieve that data. So I'm just going to kind of clone that down here. And it's going to take a big integer. So big integer will take a byte array in as a constructor. And storage.get always is going to return us a byte array. So perfect. As long as this is a numeric value stored in here, we have to ensure that, of course. And what I want to also do is I'm going to put some, actually I won't put the length checks in yet here. Let us go over and deploy this here, just so we can see. Now, normally here we would run our deploy method to distribute the initial coins to someone else. I'm not going to do that because all we're doing is recording an approval. Let's wait for another block here. There we go. So let's do an approve to start with. Approve 8. Good. And so the first parameter we're going to pass in is ourselves. So the person doing the approval here, which is that account. And then the second parameter is who we're going to delegate this out to, which is that account. And the third parameter is the amount. So here the amount will be, let's say we're going to authorize 10 tokens. Our token has 10, sorry, not 10, 2 decimal places. So we go 1, 2. We test that, everything looks good. We invoke it. You know, the next block should come along here. Let's see, what was my hash? I think that was it here. Now we can query this balance here with allowance. And that's going to take 2 hash 160s. So the first one will be the approver. And the second one will be the trustee. And that should be the FB1 here. So you see here that this value was returned. If we were to take that and decode that, that will be 10 here. So we've already covered decoding things. Okay, on that note, I want to go over a few things with this, and these are up for debate. So, allowance. Should anyone be able to query the allowance? Or should just the approver be able to query the allowance? Or just, you know, the approver and the trustee be able to query the balance? Or should it be completely wide open for a security check here? I started on the notion that only the approver they should see who they've entrusted funds to, and that should be it. But then I gave that a bit more thought, and if you just download the blockchain, anything you put into storage is recorded on the blockchain. So it is readable by anyone with a minimal amount of work. If you can write some code that can open the blockchain that's downloaded, which is just I believe it's just a level DB database, you could pull all this data out. So if someone really wants that information, they can get it. Us putting a check in here is really not going to do anything. The other thing by putting a check in here, if we are using a third-party system, they may query this allowance to see if that system is even authorized to do anything. And if that keeps returning, we're going to have to return a big integer back. So if that keeps returning a 0 back, it's going to say, well, I can't do this. So I leave this wide open now. I've changed my tune on it. Now, for the approval, we actually do have a security vulnerability here, which is quite fun. I caught this in one of my contracts here. What we're using for a key here is the approver plus the trustee address. Now, if you remember what we use for a balance here, and let's see if we've got, you know, our get balance here, is we just use the account to get the balance, right? So for instance here, if we want to get the balance, we would just pass in this. So if we were to pass into this method here, the approver of this with a trustee of null or empty, right? And then we passed in an amount of a lot. What that would put into storage would be approver concat with null, which would be this, plus an amount, which would actually overwrite our balance. So that would give us a balance of way more than there is supply, and this contract would be useless. The value of this token would go to nothing. So this is where we come back to just doing input checking, right? And I'm going to copy, I see some down here. Invalid approver, trustee, and let's clean up a little bit of that here. So now that we're making sure that both the lengths of these are 20 when they do get passed in, so that we do this here. I've seen some other people where they do the concatenation of unvalidated approver and trustee. And then they make sure the results of that length is 40, which is, one less operation. So a little bit of gas saving. I like to do things a little bit up front. I try and inherently distrust systems. So to me, getting the length of a string is probably a fairly hard operation to corrupt. So, the measurement of how many bytes are in something is usually pretty accurate. I don't think I've seen things where that's corrupted. Whereas when we call check witness on a value here, let's say check witness did something to the approver and there was some sort of overflow within that, it would exceed that. But by making sure that the length is proper, this method can run securely. Same thing with concat, probably does not have, it'd be harder to have security issues, but we are probably taking two arrays, creating a third array and copying into that. If there's a way you could trick that, you could potentially overflow something as well. So I like to do them up front. We can also check to make sure the amount is greater than 0. It shouldn't really be required here because when we actually go to do the transfer function, we're going to make sure that the amount is greater than 0, but let's just put it in there. Sorry, if the amount is less than 0, we want to fail. Invalid amount. And then we return false. So this can help prevent, data entry issues where someone puts in an amount. Let's say they had a negative in there for some reason. It would reject it right away, and hopefully they would see that with whatever system they're using instead of waiting. It might be 2 months before you go and you do a transfer, before you notice that you put the wrong value in here and it says, well, you're not approved. I can't let you do this. A few other gotchas with this method. I've heard of people where instead of just overwriting the amount like we are, if there is an existing amount, they're adding to that authorization. So they're saying if I give a trustee 10 tokens, an approval for 10 tokens, then another 10, then another 10, that the total amount is 30, which leads to some problems of now, what if I want to take that approval away from them? By overriding, we could just pass in an approval of 0 and negate their empowered amount, right? So I've heard of a few bugs like that out there in the wild. The other debate is, should we check that the approver actually has this amount in their wallet at that time? And I believe there's a few ICO templates that do this to make sure that there is the funds in there. And I think that's completely wrong. And there's a few reasons for that. The first is that I can approve, let's say, 100 tokens here, and I have 100 tokens, so everything works fine. And then once this approval goes through, I could withdraw those 100 tokens. So doing that balance check really does nothing, right? So when someone goes to do the transfer, it's going to fail because there's no funds there. And the other side of the coin is that, not to use coin as a term, I guess, but is I could do an approval, but I might not have the funds yet. That I know that someone's sending me 100 tokens and my balance is 0. So I'm going to set up an approval for this other party to do 50. So I just have to wait the 15 minutes for those funds to be there, but I want to put the approval in now. Or it could be a month, it could be a year, it could be 100 years, right? I could say, I want to approve a gargantuan amount to, let's say, my lawyer, right? To my estate. So that in the event of my untimely demise, these funds could be withdrawn by a party that I do trust. So I think I really don't agree with the argument to check this balance. If you have a point to make about that of why we should, I would love to hear it. But that's it for this video. I want to wrap this up here. I think we've done our security checks. We can also do some checks down here too if you really want to. This is a read-only operation, but again, just in case of some sort of attack on getting data. You could prevent it. I'm going to leave that in there. Anyway, sorry, I was wrapping up. That's it for now. Thanks for watching. Would appreciate the feedback. So we will see you in the next video.